Alright, for this video I've already basically done the review sheet, but I'll just point out to you how to do the problems if you get stuck on something. For these questions here, these 5 questions, every chapter there's going to be a page of graphing. For right now you don't know how to graph too much, so it's just going to be lines, but like next chapter there'll be more graphs that you know, and so there'll be more on this, but it's just short for now. So y equals -2, so horizontal line touching -2 all the time. Here's my y-intercept and my slope. So starting at 3, I go down 1/2. There's my line. Alright, here my y-intercept is -5, my slope is 1, so start at -5, up 1/1. X equals 0 is a vertical line, has to cross the x-axis at the number, so it looks like it's on the y-axis. Here, my slope is -1. It says plus 0. There's no y-intercept, so the y-intercept is 0. My slope is down 1/1. On this next piece, number 2, so f of x takes h of x, moves it to the right 4 and up 7. So that's what you're supposed to figure out here, that f of x takes the old function, moves it right and up. On this number 3, we got 3 different things to do. Domain and range. The domain, this graph goes right and left forever, like it opens up, so that's -infinity to infinity, it never stops, there's no gaps or holes. The range, you see how it goes down to -4 and it rises from there, so that's -4 to infinity. In behavior, the left side, as x goes to -infinity, the left side is going up, and the right side is going up to infinity as well. That's why they both that. Increasing and decreasing, you see these numbers are where it changes. The graph is decreasing, then increasing, decreasing, then increasing. So I know it's pointing up, but remember you have to think about the slope. The slope is coming down, a negative slope. So from -infinity to -3, second is decreasing. Then it's also decreasing in this section from 1 to 5. Then increasing from -3 to 1, and then 5 to infinity, so from here out. Remember, you use x values to talk about increasing and decreasing. Next part, select the 3 local extrema. So local are either absolute or relative. Local extrema are like relative extrema, right? Oh, it says it there, sorry. The max or mins, either one. So the extrema means extremes, right? So these 3 are going to be my local max and min, right? Because the star above the absolute maximum, that's the highest place in the graph. There is no lowest place in the graph. This graph goes down forever. So the end behavior on both sides is going to -infinity, so therefore there will be no absolute minimum. There's a local minimum right here, but there's no absolute minimum. Alright, on this next piece, we have a piecewise function, and I'm just asked to name some values. So f of -2, so if I go to -2, the graph is right there at 0. So that point is -2, 0, remember? -2, 0. 3, 2 is my next point, so f is 3, so if I go to 3, 1, 2, 3, the graph is up here at 2. 1. If I go to 1, I would think the graph would be there, but that's a hole, and it's been redefined down here, so the answer is 1 there. And -4, I'm going to go up here, so that's where the graph actually is, the darkness of it, so it's at +1. X-intercepts, I got 2 of them, right here and right here. It looks like 4.2, 4.3. And y-intercept is right there at 0, 2. Alright, down here. So I'm going to have to find, I'm given 2 functions, I'm going to have to find d of 2 and f of -5. I'm plugging in 2 here, so plug it in, got 8. Okay, did 2 to the 4th, which is 16, 16 minus 8. And then here I'm plugging in -5. -5 is squared, that's 25 times 3, so 75 minus 15 gives me 60. You can also put those in your calculator as well. So my job now is to do 3 times d2, so 3 times 8, 24, and then take away 60. Not take away 60. Oh no, I just realized that this would be plus 60. Alright, so let me fix that. So 24 plus 60, right? Yep. 24 plus 60. That would be 84. Alright, there we go. So here, the graph is giving at the left. It's a nice parabola for us. Circle all the points below where g of x equals 0. Remember, g of x equals 0. That's where the y value is 0. So these are my x-intercepts. Okay. And this right here, g of 0 equals 5. Those are my y-intercepts. Because I plug in 0 and I get 5, that would be a y-intercept. You need to remember those little facts there. Anyway, x-intercepts are right here and right here. Y-intercept is right there. Alright, down here I'm just seeing what happened from here to here. You can kind of clearly see that the angle is changed to the slope. The slope is 1 over 1 here. Now it's 3 over 1. So that's where we have this 3 here. And move to the right 4. So there it is. Stretch and right 4. Alright. On this next piece, I'm given this function, set g of x equal to 0. So I did that and solve it. So that's going to be my x-intercept, right? When the function is equal to 0, that's an x-intercept. Part B, find the value of g of 0. So I plug in 0, I get 10. This must be a y-intercept because 0, 10 is a y-intercept. Alright, piecewise function. Given this piecewise function, f of x, I want to find these two places. So I got to decide what category it's in. So 4. 4 falls into this category here. Means I'm going to be using 4 right here. So 1/4 times 4 is 1. 1 plus 3 is 4. 7. 7 falls into this category. So there's the answer, -6 all the time. -5 falls in this category. So I'm putting a -5 in here. -5 minus 4 is -9. -9 squared is 81. Alright, down here I have new equations. So look, this first line right here, the equation of that line, it starts at -3 and it goes up 1 over 1. That's where you're seeing this. And this is only good for things behind 1, to the left of 1. So everything less than 1. See, that circle is open. And everything 1 or above is going to be this line here. Now, I can see the slope is down 2 over 1, so I see that. I have to continue it on, and here would be the y-intercept. It starts at 2, goes down 2 over 1, down 2 over 1, down 2 over 1, but it only begins after x is equal to 1. Alright, so these are your line equations, and these are the conditions at which they are used. Alright, down here below, so this is just some little function operations. Here's my three functions, f of x over g of x, so I am taking this over that, so I can actually divide these by 3 and get my answer. Fraction, so I'm taking this minus that. So I have no x squared here, and when I take away that x squared, that gives me -1x squared. I have -3x minus a -5x, so that's -3 plus 5, so it's positive 2x. And I get 18 minus 6, so 12. Here's a composition, f of g of x. So that means what I am doing is f is the boss. I'm going to take this and put it right there. You see I did that there first. And it's just a matter of cleaning it up. Distributing. When you distribute, it looks like the -18 right here, and this 18 wipe each other out. Alright, g of f of 5. So look, find f of 5 first. If you put 5 into this problem, you get 3. And then you're going to work out g of 3. So you put 3 into this problem, you get 9 minus 15 plus 6, so you get 0. Right. Letter H, you're doing the inverse. So remember, this is y equals -3x plus 18. So what you're doing is you are changing the x and y, so you're making it x equals -3y plus 18. And then you're solving for y. You're taking away 18 and dividing everything by -3. And getting this answer. Alright. And this last part, g of h of x is what that means. That's another way of writing composition. It's kind of like writing it like this, but the letters are backwards. So that means that we're taking h of x and putting it into g. So we're taking this and putting it in here. So that's kind of like what we just did up here. Turns into g of 3, so it's 0 again. Alright, number 13. To prove that two functions are inverses of each other, you plug them into each other. So you have to show that plugging them into each other both gives you the letter x. So f of g of x. I'm taking this and I'm putting it here. So when I do that, this gives me x minus 10 but plus 15. So frankly, at this point you kind of know they're not inverses because that didn't work. They both have to work. But I went ahead and did the other way here to show you also that turns into x plus 3 minus 2. It also doesn't work. So you have to get x for both of them, and both of these are wrong. They're not inverses. Alright, last little bit here, just reading the table. F of 3. So I go to 3. Here's f. The answer is 4. G of 2. I go to 2. There's the answer. Alright, so 3 times g of 0. So 3 times g of 0 is 6. Plus f of 4 is 2. Here's my answer. F of 5 minus f of 3. F of 5 is 0. F of 3 is 4. So 0 minus 4. And then 5 minus 3 on the bottom. Alright, find x when g of x is 7. So g of x is 7 right here. X must be 1. This turns into f of g of 2. So I find g of 2. So g of 2 is 4. This turns into a 4. So that means I'm doing f of 4. So f of 4 is 2. For values, there's f of x equal g of x. So it happens right here at 1. It also happens at 4. What coordinate is the x-intercept of f of x? So an x-intercept has to have a 0 for the y. So when I look at that for f, it's right there at 5. And the y-intercept of g of x is when x is 0. So when x is 0, g is 6. Alright, this one right here, we're going to draw this piecewise function. So 4 is my breaking point. So it's everything before and after 4 are different. So 2x minus 7. So I start at negative 7, I go up 2 over 1. So I draw that whole line, and then I erase the part of it that is after 4. Because I want the point where it's at 4, I want that to be open because there's no equal bar, and I'm going to keep the left side. And then, to the right of 4, this area right here, so for the number 4 and to the right, I use the answer of 5. So just have a horizontal line. Because remember, this is y equals 5 when you are 4 and above. So here I am at 4 and above, y equals 5. And that's it. Alright, bye-bye.